So in this lesson, as I mentioned before, we are continuing the demo of a role-based access control or authorization. So we are going to continue the IAM journey in the case of roles and access and role-based access control. So let's get in the topic. So let's try to summarize what we've been doing so far. So we had the AWS account where we had the login pages and things like that. And in this account, we had a lot of different resources. We have seen EC2 instances. We have seen DynamoDB. We have seen IAM, so many different things inside. So many different objects or object types. I wouldn't call object, probably object type. Object is when you create an instance. That's when object comes into the picture. So many different things are there in this AWS account. So this is the AWS account, which has an account number. Doesn't really matter to us. So initially what we did, so this is the laptop, we are seeing the screen. Initially what we did, we established the SSL connection to AWS. We made sure that we are giving whatever we are giving to AWS and no one else. We have verified the public key of this particular URL. All the things we have learned so far, all the encryption, decryption, public key, RSA, Diffie-Hellman, all those things comes into the picture, hashing, everything. So that is the single most important part. If that is broken, everything else is broken. So we have verified that particular bit, the TLS. Now, what happened after that? The AWS asked us the username and password. We don't have MFA, which it was not happy about. And we logged in using the root account or the admin account. This is very common in almost all kind of scenarios. By default, everything is root in any system. God level permission. That's what we normally say in the security world for root account. So we have used the root account and password for this particular AWS account. And we got access to every single thing in that account. So that's the screen we have seen in the first window, the AWS Management Admin Console or AWS Management Console with root permissions. So that had access to all these items because it is a root account. It had access to everything. Now, what we did, we gone to the IAM. So let me draw that. Suppose this is the IAM. So we gone to the IAM and created a user. And to that user, we attached a policy. And we restricted the permissions of that user. What is the permission we have given to that user? EC2 full access. Suppose this is EC2. EC2 full access. It doesn't matter to us much about the details of the policy, but what matters is that we have applied a restrictive policy to this particular user. Now what we did, we took another browser. Why we took another browser? Why couldn't we do it in the same browser? Because this browser has the cookies for this particular user. See, everything we have learned is coming into the picture. If you collect the trace, the fiddler trace, you will see cookies, just like we saw in the case of Gmail. This whole thing, this authentication has been converted to a number. I have not yet looked into an AWS authenticated cookie before, but I'm pretty sure even I don't have to look, there will be a cookie. Otherwise, it'll ask for authentication every time. Just like the Gmail, it has the cookie. Because of that reason, we had to use another browser or the same browser with incognito on. Doesn't matter how, we have a different browser and we did the exact same thing. We gone to AWS Management Console and we entered the account number, username and password. Again, we got into the admin console. We did all these things, all the TLS and all these things we did here as well. TLS is always there. TLS is the basics. You can't do any kind of secure transaction over internet without TLS. TLS is must. If TLS is broken, everything else is broken. But at the end of the day, we gave the username and password and we got a restricted access. Let's store that in a different color. Just to the EC2. This is the only access we got for this particular user because of this particular policy. So that's what we have seen so far. Now, what is that we have not seen? The thing we have not seen is that we have directly applied a policy to a user. That is normally not done. Remember, we are talking about a role-based access control. Role-based access control. RBAC. We are not talking about user-based access control. What we have done here is user-based access control. That's not what we are after. We are after a role-based access control. User-based access control is not manageable. Now, what we're going to do, we are going to create a role. We'll see groups as well, but first we will understand what is a role in general. Basically, at the end of the day, it is a group of users. You can think of role as well as groups exactly same, but I'll explain the subtle differences briefly because it's very specific to AWS. For example, in Active Directory, the olden days, it is all groups, different Active Directory groups, from which almost all these concepts are derived from. In fact, it is because it's one of the first products out there which implements all these concepts we are discussing, Microsoft Active Directory. There have been other directory services from Novell and things were there, especially in the Linux domain, but nothing was as popular as Active Directory. Almost 30-40 years it was ruling the world. Now things started changing. There is Azure Active Directory, all the other identity providers and things like that has popped up. But the story is apart. What we are going to look is a role-based access control. What we are going to do is we are going to create a role and add the user to that role, and the user will assume that role. So there is a little more work to do, and we are going to see everything one by one. So coming back to the setup we've been discussing so far. So this is our test user account. We have logged into console using test user account. It has the same permission. We have not made any modification. So if you try to access something which doesn't have permission, so we'll get an access denied like this. But it has access to the resource which we have given permission, which is something called EC2 instance. Doesn't matter what EC2 instance is from our discussion perspective. Now let's go back to the admin console. This is our admin console. As you can see, that particular policy is applied to that particular user. Now let's remove this policy. So we don't need this particular policy for this particular user. So what we are going to do, we are going to create a group or a role in this case. From this discussion standpoint, I'll be using role and group interchangeably, but it's completely different from AWS perspective. Be aware about that. I'll try to use the word role itself so that I'll be accurate from the AWS terminology perspective as well. Also, I have seen a lot of new role-based access control. The word role is more common instead of groups. For example, Kubernetes. Kubernetes, it is called role, although it is primarily used like a group in pure AWS terminology. Doesn't matter, as long as you're understanding the concept, it is completely fine. And in the end of this particular lesson, we'll discuss the subtle difference between role and user, at least in the AWS. Very specific discussion, probably pretty much all the cloud role-based access control mechanisms has this kind of difference as well. So we'll discuss that. For the time being, what we are going to do, we are going to remove this particular policy. So click on remove. So the policy is removed and pretty much this user doesn't have any permission whatsoever. And let's go back to the console again of this particular user. If you're confused what user I'm using, this is where you see user at account. So right now it is showing no errors here, at least in this case. Let's refresh it. Let's see if it has the same permission. So as we have removed, we are getting all these API errors, capacity reservation, this, that. A lot of errors we are getting because we have removed the permission from the user. The user doesn't have any permission whatsoever. Whatever it touches, you will get an error. EC2 IAM. IAM, it didn't have permission anyway, so there is no point checking it. So we have removed all the permission from test user. Test user doesn't have any permission whatsoever. Now what we are going to do, we are going to give the same permission to this user in a different mechanism. What we are going to do is we are going to create a role and we are going to assume that role from this particular user. So let's get to it. So role, I'm going to create a role, create role. So as you can see here, the complexity of this thing already starting to pop up. As you can see, the role can be assumed by a lot of different entities inside AWS. Select trusted entity. Select trusted entity. What is trusted entity? Very important thing to understand. conceptually. Forget about AWS, forget about IAM, forget about role-based access control, everything. Trusted identity is a very important concept. So trusted identity or trusted entity in this case are a group of entity or identities. It has that number anyway, so it's an identity as well. So trusted entity is anything which come up with a number and can be part of this role. Whatever role permissions we are going to give next, that's what we are going to do next. Step 2 is permissions, add permissions. So the role has two things, trusted entity and permissions. This is exactly what we discussed before. Who can be part of this role? XYZ people can be part of this role. Now what they can do, that is what it is mentioned here. So in this case, what are the different things? AWS service like EC2 Lambda, all these different software and hardware component. For example, EC2 is a hardware component. Lambda is like a software component. It can be a Kubernetes pod, which is a container. Again, software plus virtual hardware, if you know what I mean. Now, AWS account, that is another entity which can be part of this particular role we are going to create. Web identity, SAML, we'll see some of these things in the future presentation. Basically, different types of identities which is available within the scope of AWS. In this case, we are going to use AWS account. Allow entities in other AWS accounts belonging to you or third party. So some AWS account. In real world, these are the two common mechanisms to do it. Web identity and SAML. SAML we will see in the next few sessions. And this is also very common AWS service. Probably not the EC2, but for example, Kubernetes pod and things like that is pretty common. EC2 is also common if you're using EC2, but doesn't matter to our discussion. It's all AWS specific things. Just I'm putting out there because I'm seeing in the screen right now. But in our case, we are going to select this option because ultimately we want to give the test user. This is the account, test user is present. So all these things are for additional security. I'm going to click next. And what that user can do. This is all about those permissions. As you can see, it is the exact same permission. It is all about different objects. And inside different objects, you can do many other things. In this case, for example, API gateway star. So in this case, application auto scaling, this is the object and this is the API or functionality within that object or action within that object. Same aeroplane and airport analogy applicable here. So what is the policy we are going to select? We are going to select the same policy EC2. EC2 full access, that's the one we have selected, I remember. And I'm going to click next. And as you can see, trust policy, it is going to trust this whole account and everything coming from it. And permission is EC2 full access. And if you want, we can create some additional tags and things like that. So AWS specific things I'm going to create. I have not given the name. I have to give the name for the role. Test role EC2 full access underscore role. It's always good to name things ending with the object type. It's all just best practices. So the role has been created. Now view role, trust relationship. So this is all AWS specific way of doing certain things. I'll explain a little bit more about this thing right here. Let's make it work first and then we will see what's being done. I'll briefly discuss about last access and revoke and things like that. But at the end of the day, we are not going to dig too much into AWS IAM or any cloud IAM for that matter. Let's give the respect to these topics. They require their own training. I'm happy to provide one if anyone is interested, but that's not the intent of this particular training. We are trying to understand role-based access control, and this is a production example, a live cloud example we are looking at. That's all about it. And what we are looking at is a perfect fit for that. We don't have to get into these kind of details because these details are different for different platforms. We are trying to have a generic conceptual discussion with enough concrete example. That's what we are trying to do. But we will touch upon these kind of things as and when we see it. Now, let's see what happened to our user. What I'm going to do is that I'm going to refresh this, not change at all. Why? Because we have not connected this user with the role we have created. We have created a role, but this user doesn't have any connection to that role. As well as there is a specific permission we have to give to this user to be part of that particular role. Let's do that. So we are going to give that permission to this particular user. Again, same thing we have done before. We are going to give a permission to assume a role. It's called assuming a role, basically being part of that role. So this is the same place we've been in the last lesson, add permission. If you remember, this is how we have added that permission to that user when we created it. But we have removed all the permission in the beginning of this lesson. Now we are going to add a particular policy. So I'm going to click on attach policy, and unfortunately the policy we want to have is not built in. So we are going to create a policy just for the specific purpose. So these are all built-in policies, which is very common in role-based access control systems, built-in policies. But some of the built-in policies are not enough for your purpose. In that case, you can create custom policies. So let me show you how to do that. So in the IAM, we go to policies, create policy. So in this case, it's all about objects. Remember the objects we have? What object and what functionality of that particular object. That's what it's all about. We can complicate further with the name of the objects and conditions and things like that. But otherwise, it's pretty straightforward. It's all about object. Let's have a look at the drop down. So we have so many types of objects. These are the different types of objects in AWS. So many is there. So you can type something and filter. In our case, we are going with something called STS. It is a token service. It works very closely with IAM. And what I'm interested in, assume. So only one action I'm allowing for that particular user. It is called STS assume role. Right now, I'm going to put it for all ARNs. I'm not going to put much filters. I'm going to remove all the other conditions and things like that. I'm going to click next, and I'm going to put this policy name something, test STS assume role policy. Let me create this and I will explain what's going on. If you're kind of lost, there's a chance that you may be lost if you're seeing this for the first time. So customer managed. This is the policy we have created. Let's click on that. So policy is about permissions. What are the permissions? So policy is all about allowing something. That's the only thing policy does. Allowing something. By default, everything is denied. You don't have to create a policy to deny something. At least in the case of AWS, the IAM thingy we are looking at right now. But all in all, it's all denied. Now, what is allowed? The object type, STS, doesn't matter what is STS in this case, and assume role, that is the API. Think that this is the cockpit of the aircraft, and this is the fly plane API. And that is the only thing we are allowing to this particular policy. Now, the policy is standalone. This policy has no connection with our test user. The policy is standalone. If you look at the policy, it is standalone. It has no connection with our user so far. Now we need to connect this policy with our user. Now for that, we need to go to our user, test user 1, and permissions, add permission, just like before. Again, attach policies directly, and then we're going to select customer managed, and we're going to select the policy we have created. Click next and add permission. Now you must be wondering why we are doing this. Why we are adding this strange STS assume role to this particular user. This is to allow user to assume that role, be part of that role. That is what allowing this user right now. We'll see that. We'll see all the experiments before we go. So right now what we can do is we can go to the test user and see what happens. So I'm going to refresh this, no change. So what we didn't do anything. We did do something. Now what we can do is we can switch role. This particular user can switch role. He can take the hat of a pilot. That's what he's going to do. Let's do that. So we are going to the roles and we are going to look at the role we have created. So this is the role we have created, and we are going to copy this ARN just for the sake of making it easier. And if you click here, right here, you can see switch role in the AWS, and we need to put the account details and things like that. So let me copy paste that thing here. So this is the account and we need to put that here, and this is the role name. We can put the ARN directly here, but just I don't want to confuse you with all the AWS specific thing. But the idea here is that we are going to switch to that particular role we have created from this particular user. I'm going to click on switch user. If all gone well, switch user will work, and luckily it has worked. As you can see, now these access denied things have gone. Now from where this permission is coming? The permission is coming from that particular role. You can create any number of users now and let them assume this particular role. And you can centrally manage the permissions of all those users by just this particular role change. Now, what I'm going to do is that I'm going to show you what happens if we remove that STS thingy, which we have added to this particular user. So the only permission this user is having at the moment is STS assume role. So I'm going to remove this. If you remember, this is the only permission this user is having, and I'm going to remove it so that you will understand what that thing does. I'm going to removed, the policy is removed. Now let's go back to the user and let's refresh this. There is no problem. Now I'm going to switch back. There is a button called switch back. I switched back. Now we are getting the API errors. Now let's try to switch again. Switch role. Let me get the ARN for that role which we have created. So this is the role ARN, and let's try to switch it. So I'm going to press switch role after entering all the same details we have entered before, and we are getting an error. Invalid information in one or more fields. Check your information or contact your administrator. So this is a very security specific message. You can see that it's not giving any clear indication. This is common with all the security related error messages. It is not telling you that you don't have STS assume role permission or something like that. It is simply giving a very generic error message, because this can be an end user, because you are not giving any secrets here. As you can see, there is no secrets here. There is no number. You can be part of any account. That's why we are getting a very generic error message from AWS, which is the correct thing to do, because this account can be anyone's account and this role can be any account's role. That's why we are getting a very generic error message. Now this switch role was working because of that STS assume role permission we gave. Let's give it back. See users, again test user. So this is the test user we are right now inside. This is the test user which is trying to switch the role. Again, we are adding back that permission. Add permission. We can create inline policy as well. Pretty much that's what we are kind of doing indirectly. All types, customer managed, assume role, next, permission, and that's done. One policy added. Now we are going to click the button again, switch role, and it worked. And we are back to the page again. Now another thing I would like to show you is I'm going to remove the permissions from that role. So we have the role here. So role is here, and this is the role permission right now, and I'm going to remove that. So easy to full access, remove. So the role's permission got disappeared. We have deleted. The role doesn't have any permission. And now if we come back to this thing and if we refresh, we are getting API error because the role permission has gone and we are within the role right here. If you look at here, it is a role and it is not the username anymore. So it is the role which is in the permission part. Very important thing to consider. Now one more improvement we can do is we can create a group and add all the users to the group, and instead of giving that inline policy or the customer managed policy to that user directly, we can add user to the group. So let's do that. So STS assume role group. We'll put a test in front. So we're creating a group and add users to group. So I'm going to add this users to the group. Again, I feel nostalgic when I do this because typically this is how AD works, exactly how Active Directory. Create user group. I have created group and group has one particular user, which is our user. Permissions, as you can see, permissions are everywhere. Users can have permission, roles can have permission, as well as group, in this case, can have permission. That's what we are going to do. Add permission, attach policies. Again, pretty much the same thing we are seeing again and again, as you can see. Customer managed. This is what we are interested. Our STS assume, right? Attach policies, and we have attached the policy to that particular group this time, right? Now we can remove that policy from the user. So let's do that. User has a policy. So this we can remove now because this policy is with the user. We don't need that because user is part of the group. So I'm going to remove this. Now let's see if it is working. We need this particular role. So I'm copying this ARN again and going here. We need to switch back. So I'm switching back. We are not expecting this errors to go because our role doesn't have permission. We have removed that. So be aware about that. Keep that in mind. Switch role. Again, we are copying, taking the account number, Control V, Control C, Control V, switch role. Yeah, it worked. The role has switched correctly. Now let me remove this particular user from this group. So this C group, user group. I'm going to remove this particular user, remove, and I'm going to repeat the process to check if it is going to work. Switch back. Now again, switch role. The role name was there in the bottom, but we can go in our usual route. C role ARN, Control V, Control C, and switch role, and it is not working as expected. Now let's add back the user to the group. So add users. This is our user and user. Now we are expecting it to work. It'll take some time sometimes because some of the databases has to reflect. At the end of the day, backend of this is some kind of database they are running inside the Amazon Web Services. Some of the things can take a couple of seconds at times after you make the change, but it has worked. And now this particular user doesn't have any permission whatsoever. So this policy is attached via this particular group, as you can see from the group, not individually attached to the user. Now let's put that permission back to the role. Add permission, attach policies, EC2 full access. That's the permission we are giving to the role. As you can see, it has come up here, and now the role also has been switched and it should work. Now this looks like pretty neat AWS implementation. I wouldn't say it is production level because we need to have identity providers and things like that to be enabled. Hardly we ever managed users inside IAM in a production scenario. It is always a different identity provider, which we will see in subsequent lessons. Let's have a quick look at the role once again. So what is a role? So role is the connection between permission. So these are the permission. What can be done within the perimeter of the security? Can you fly a plane? Can you clean a plane? Can you make food for the passengers? So all that kind of things. That is what this permission is all about. Now, what is this? This is the other end of this coin. So there are two parts for a role. One is the permissions. Next is trust relationship. That's kind of the AWS terminology again. But otherwise, it's all about who can be part of that role. Who all will have this permission which we are giving here. That is this particular column here. So what this is saying, any user in this particular account, that's what this is saying. It's pretty unsafe kind of permission we have given here, but this is all for testing purpose we are doing. We are not doing any kind of production thing. We are not mentioning any kind of conditions or any filters, additional filters we are mentioning, and we are allowing everyone pretty much from the account. In our case, we used our user, test user one, and we have given STS assume permission to that test user. Now, this is specific to AWS. What's the difference between groups and roles? So groups are in AWS, just like the name says, group of users. Whatever we are mentioning here is pretty much permanent. On the other hand, roles the internal access mechanism is completely different. So there is a ticket obtained temporarily. There's a password. The number we are talking here, remember we talked about the number to access things? That number changes every time in the case of role. That is what in AWS terminology they call the STS token, which is again nothing but a number. That number changes. The token gets renewed in a periodic fashion, which means the role is kind of considered more secure. And as you can see here, role can have a lot more trusted entities, not just users, right? AWS Service EKS, EC2, CloudFormation, StackSet, organization, a lot of different services can be trusted. All these services, trusted entities can assume this role, which means that not just humans or users, but others also, other things, services, SAML, authentication, all can be used for assuming role. But conceptually, from our training perspective, we can assume that it's more or less the same thing. It's just user groups with additional bells and whistles for security reasons. That's what role is all about. In AWS and almost all cloud platforms, there is something equivalent to role. Always use role. Whenever you have to use or feel to use groups, there is a high chance that it is role, but not groups. So that is a subtle difference from users and groups in cloud scenario, very specific to cloud. Active Directory and a lot of the on-prem things doesn't have these differences, but it's very cloud specific. So we have seen user groups, group of users. It can have policy or permission. I'll be using both of those things in a synonymous manner. Policy is a group of permissions at the end of the day. And users are just users, just like test user one we have seen. So one of the things you can try to do is that create another user if you're doing this demo by yourself. Create another user and add to this particular group right here and see if he has the exact same permission when he assumed this particular role. That's the whole point of group and roles. So that's something you can play around as part of exercise if you're doing this by yourself. Policies, we have seen. Policies is all about what can be accessed, different services, different resources, different objects within AWS. What can be accessed? That's what this is all about. So if you go back to roles, once again, you will see a couple of details here. Trust relationship we have seen. Tags, trivial, just a naming thing. Let's see last accessed. So this is very interesting information. So last accessed service, elastic load balancing, Amazon EC2, CloudWatch, granting permission. So this is very useful for auditing purposes. Very important information. This is the reason why we are demonstrating. So we will have a session on monitoring and alerting, auditing in terms of security, very important part of security. When you have a breach, when you have an issue, these are the things which is going to help you. Also, it will help different monitoring and alerting tools to create an audit and warn you that, hey, you have given a lot of permission to something. So this kind of things. So today, this has been accessed, elastic load balancing. If you click on this thing, you will get more details. I'm not going to the depth of these things because it's all AWS specific. And sessions. So this is again that number thingy I'm talking about. So there are active sessions, which means active numbers. You can think of it like a cookie. For example, the Gmail we've been seeing before. The Gmail was working because that cookie was active. The cookie we gave to the Gmail was active, and that cookie meant something to the Gmail server. That's why we were able to see the Gmail without username and password. That number, the number we are getting after authentication. Like that, we are getting a number here also, which we call STS token. And this is to revoke that token. And you can mention different conditions to revoke and things like that. Again, very specific to AWS, but I'm just explaining all these things just that I'm seeing in the screen right now. Now, before we go, what we can do is we can have an overview of what we have seen so far. Probably if you're seeing IAM for the first time, you may have to review it again, the whole session, and you may have to read or ask me questions about it, because I have explained a lot of concrete details which is specific to a cloud provider. I could have simply gone through some theory only, but that doesn't make the point. We need to see something real world. Otherwise, it's all going to be theory. And when it comes to real world, this kind of complication and details comes into the picture. So you have to be prepared for that. That is a difficulty this particular lesson is going to have. But IAM is a very common thing, irrespective of any cloud provider you're going to go. IAM is going to be there. In fact, this is going to be there in different forms and fashion in different enterprise product. If you have an enterprise product which is used in a big company and if doesn't have a role-based access control, don't even use it. If it is a company which is 50 people or 20 people, don't worry about role-based access control. But if it is 500 or 5,000 or 50,000, you need role-based access control, or you can get into big troubles later. So being said that, let's have a quick look into the overview of what we have done in the Blackboard. So again, we have the AWS. Let's draw it a bit bigger box this time because we need a lot more things inside that. All the roles and stuff is going to be within that account. And we have the IAM here, the identity and access management of the AWS. This is the AWS account we are interested in. And this is the IAM, identity and access management. And this is the EC2, which we are trying to get access to, EC2. And these are the other services which we don't have access. The test user one is not going to have access on this. Other things. It's like a huge list of things, like hundreds, if not thousands. Now what we did, root account. So this is the root account. Whatever I'm going to draw in red is a root account. So this is the root account. So this is my laptop right here, one which you are seeing the screen. And I have logged into the root account. I have created a user, test user one in the IAM, test user one. And then what we have done is we have created a group, test group. And then we have created a policy, test policy. I don't even remember the name of the policy, but you get the point. We have created a policy. What that policy can do? The policy can STS assume role. Can that policy access EC2 instance? No, the policy cannot access EC2 instance. That is not the policy is for. Now, we attach this particular policy to this particular group, the test group. Then we added this user to this particular group. And this user is getting this permissions through this group. We can add n number of users. We had only one user, but we can add n number of users. That's one of your exercise to this particular group. And all those users will get this particular policy, STS assume role permission, right? Now, what we did, we created a role. What the role does, role has two things. One is trust relationship and permissions, right? Permission is what that role can do. What that role can do, that role can assume permission towards EC2. That is the permission that role is having. Now, who all can be part of that role? That is the trust relationship. So we have given trust relationship to pretty much everything in this whole account. Pretty bad thing to do, but we are just testing thing out. Provided that user or that entity has STS assume role permission. So that's why we have given STS assume role permission to this particular group, so that users in the group will be able to assume this particular role and get these permission to access this EC2 instance. Now, let's take the case of our test user. Our test user has logged in using his password and gone to the IAM. Now in the IAM, he got this particular permission. That's the only thing he has. STS assume, let him do just like the name says, assume a different role. And that's exactly what this guy is going to do. This test user, very tricky guy. He's going to assume this role, right? He has the permission to assume this role. And he has assumed that particular role. And then he has started all the EC2 instances because he got the same permissions which that role is having. He don't have access to any other resources. None of these things are accessible to him because he can assume only that particular role. So create a couple of different users, groups, and try different roles, permutations, and combinations if you want to try this out. But otherwise, it's pretty straightforward, typical role-based access control. Now, if you want to learn more, you can try to figure out this pattern in different products. There are so many free products out there you can download and test. One comes to my mind is Nexus. You can search for Nexus. It's a repository, Nexus repository. I've been doing some work in Nexus recently, and I was just remembering this is exactly same in Nexus role-based access control. It has its own role-based access control mechanism. VMware vSphere, it's not very free, but if you get a chance, you will get it. The role-based access control. Another thing which comes to my mind is Kubernetes. Kubernetes has a very clean subset of a role-based access control. If you want, we can even have a quick look at the documentation. Kubernetes role-based access control. Pretty straightforward, small subset. It doesn't have any kind of complication like IAM is having. IAM has a lot of conditional clauses and things like that, but it has the role and role binding and things like that. You can read the documentation. It's all in YAML. This is the example of a role. So in the case of role, as you can see, this is the object. This is the permissions of actions. It's not exactly same as the AWS role. Role binding is binding a user to a particular role. So role plus role binding is kind of AWS role in here. So that kind of difference, you can map it out. You should map it out in different products, slightly different implementation to achieve the same goal at the end of the day. As you can see, this is a user and we are connecting with a role. And the role has the definition of object, aeroplane, and the actions. Clean, fly, sit in the passenger seat, a lot of things like that. So a lot of different products has this kind of pattern to achieve similar things. So that is another exercise you can try do if you're working in a company, or if you're not working in a company, you can look at something like Kubernetes to understand the pattern, figure out the pattern, exact same pattern we have discussed. So to conclude, we have seen a solid example of authentication and authorization, which is IAM in AWS. This is a very typical scenario in which you will see almost everywhere in a corporate environment, whether a particular place like an airport has different kinds of people who has different access. One of the very important security attributes to any environments like that. Next, we will see some of the related topics around authorization and authentication. Thank you for watching, and I'll see you in the next lesson.